In 4.2, we are looking at relationships between position, velocity, and acceleration. We've already introduced this, so it's not super new, but we want to go into a little bit more detail and talk about the relationship to speed as well. So we have a position function, and WRT here, this means with respect to. So it's a function with respect to time. Frequently, it's written as S of t. If it's a vertical position, then you might see H of t for height. But we also have X of t and Y of t functions. And both of these mean we are traveling on the axis. So on either the X or the Y axis. Be careful with these as far as graphs go, because if we're looking at, let's say I'm looking at a particle that is moving left and right on the x-axis over some time. Well, my horizontal axis is t for time, and then my vertical axis is x of t. Normally, we're used to seeing the x-axis horizontally, the y-axis vertically, but here x is the output, or the location where the particle is on the x-axis is the output of the function over some amount of t. So t is the independent variable. So just be careful with especially that x of t. Y of t is a little more intuitive, but x of t can be a little bit tricky. Okay, velocity is the rate of change of position over time. How far did we go over? How long did it take us to do that? So since it is a rate of change tells us to think derivative. So v of t is the derivative of position, so s prime of t. Okay. Now, as far as linear motion goes, we are only dealing with linear motion, meaning only one direction at a time, but could be forwards or backwards. Or so really, if we have the velocity is positive, this means that we are moving either up, to the right, or forward, just depending on the context of the problem, but we won't be doing more than one. We won't be going left, right, and up, down at the same time, okay? If velocity is negative, this means we are moving down, if it's a vertical position function, or to the left, or backward, okay? Again, depending on the context. And then v of t equals 0, that means that we are stopped, okay? All right, then acceleration. Acceleration is the rate of change of velocity over time. So again, rate of change makes us think derivative. And so a of t is the derivative of the velocity function. And if it's the derivative of velocity, that means it is the second derivative of the position function. Okay. Now, speed, we have not really included very much here, but we're going to include speed in our discussion today. So speed does not indicate a direction. Can speed be negative? No, it cannot. Okay. Nope, we cannot have negative speed. Velocity can be negative, and having a negative velocity value, just like we talked about on this chart here, means that we're going the other direction. So backwards or to the left or down, the opposite of if velocity is positive. But speed cannot be negative. So related to velocity, speed is actually the absolute value of the velocity function. Okay, so what I want to do now is I want to look at an easy graph of velocity. This is just a basic parabola. It's got y or x-intercepts of 1 and 3. Go ahead and put some numbers on here. Okay, it's opening upward. And then we're going to also graph speed and acceleration based on the same velocity graph. And then we're going to use those to answer some questions about whether the function is speeding up or slowing down or something else related at various intervals, okay? So the first thing I want to do is I want to graph the speed and acceleration graphs based on velocity. Well, velocity is the absolute value of, speed is the absolute value of velocity, so I'm going to graph the absolute value of this function. When I apply an absolute value onto a graph, essentially anything positive, or really I should say non-negative, stays the same, has the same output, but anything that is negative has the opposite output. So on the interval from 0 to 1, we still have this part the same, and then same thing over here from 3 to infinity, or 3 to 4, doesn't really matter. And then this piece down here gets flipped up above, and so I have something that looks like that. Okay, it's a little off center. Let me try again. Better. Okay. And then the acceleration graph, acceleration is the derivative of velocity. So let's talk about derivatives. If I were looking at the tangent segments, if I were drawing a bunch of little tangent segments along here and looking at those slopes, I would notice that here the slope is very negative, and then here it's less negative. Here it's less negative, less negative. Here the slope is 0. Now the slope is slightly positive, more positive, more positive, more positive. So then the values for that, okay, become the points on my acceleration graph. I do know right here at x equals 2, I have a horizontal tangent, meaning a slope of 0. So that means acceleration has a value of 0. And then again, we were very negative going to less negative to 0. So very negative, less negative to 0. And then slightly positive here, more positive, and increasing. So this. And if this one is a parabola, it does make sense that acceleration would be linear because the derivative of a quadratic is a linear function. Okay, so now let's look at this table here, and I'm going to have to kind of see if I can fit all of this. There we go, that's pretty good. So we want to, in each of these boxes, we want to say whether the particle or object that's moving with this velocity and speed and acceleration graphs is speeding up, slowing down, has a constant speed, or is stopped, okay? My suggestion is that you pause it and you try and fill in just this top row, okay? Try and fill in the top row, and then resume and see if you get the same thing I do. Okay, so for this first part, I'm looking where velocity is positive and acceleration is positive, okay? Velocity positive and acceleration positive seems like I should be speeding up. Let's look at an interval on the graph where these two things are both true and see if that is accurate for speed. So let me show you what I mean here. I'm going to use my highlighter. When velocity is positive and acceleration is positive, so velocity is positive on 0 to 1 and 3 to 4. Acceleration is only positive from 2 to 4 or even further. So I'm looking at this piece right here. This is the interval. So 3 to 4 or 3 to infinity is the interval where both velocity and acceleration are positive. If I look at my speed graph on that same interval, I do notice that this graph is increasing. So that does tell me, yep, speed is increasing. So we are speeding up. Okay, and then when velocity is positive and acceleration is negative, seems pretty intuitive here that we're slowing down, but let's check an interval anyway. So positive speed, negative acceleration, or sorry, positive velocity, negative acceleration is going to be the interval from 0 to 1, or negative infinity if you want to follow the arrow, okay? And on that same interval, what is speed doing? This graph is decreasing, okay? So, yep. We are slowing down. Oops, that's a highlighter still. Okay, and then lastly, when velocity is positive and acceleration equals 0, okay, well, is there anywhere where that happens? Velocity positive and acceleration. No, actually, there's not on here. So let's just think about what that means. This particular graph, it doesn't happen. But if velocity is positive and acceleration is 0, that means that our speed is not changing. So we have a constant speed. Okay, go ahead and pause. Try the next 3. So here we want, for this box, I want a negative velocity and a positive acceleration. Okay, this is the one that, if any, is more likely to trip people up because they hear positive acceleration, we must be speeding up. But again, let's look at an interval where that may be happening. Okay, negative velocity and positive acceleration. Velocity is negative from 1 to 3, but acceleration is only positive on 2 to 3 of that interval. So from 2 to 3, this is what I'm looking at. Well, on 2 to 3, what is the speed graph doing? The speed graph is decreasing. So we are actually slowing down, not speeding up. So just having a positive acceleration is not enough information to say that we are speeding up. In this case, acceleration is positive, but since velocity was negative, our velocity is becoming less negative, meaning getting closer to 0 So our speed is that we are slowing down. Okay, when velocity is negative and acceleration is negative, that's the remaining interval here. Let's do that. And have we done a blue yet? Nope. Okay. So on 1 to 2, we see that our velocity and acceleration are both negative. And then on the interval 1 to 2 on the speed graph, the speed is increasing. So we are speeding up. Okay. And then when acceleration is 0, we actually do have a point here for where velocity is negative and acceleration equals 0. That's happening at t equals 2. Well, right here, we are neither increasing nor decreasing on speed. So again, we have a constant speed. Okay. All right, for the last 3, when velocity equals 0, these, I don't know if these are represented in the, I guess there are a couple places where velocity equals 0. So, all right, so when velocity equals 0 and acceleration is positive. So velocity is equal to 0 at 1 and 3, okay? So velocity equals 0 and acceleration is positive. That's happening over here at 3, okay? Well, what is the speed doing at 3, What is that speed doing? How would we describe it? So speed was decreasing and then it's increasing, but what is the speed right at t equals 3? The speed is 0, so we are actually stopped. Okay, so when velocity equals 0 and acceleration is positive, we are stopped. This happens at t equals 3. And then when acceleration is negative and velocity is positive, well, that's happening at 1, okay, like this point here. But again, we're stopped. So really what we see is that, so this is at t equals 1. What we see is that if velocity is 0, it doesn't really matter what sign acceleration is. We are still stopped, okay? And then same thing here, stopped. And then the speed would, constant speed, yes, but it would be 0, okay? And so you might be thinking, well, that doesn't make any sense because how can we have a positive, like at time 3, how can we have a positive acceleration and say that we're stopped if acceleration is increasing? Well, it is increasing over an interval. However, at that briefest instant, we are stopped because if you change directions, okay, if our particle is going, is going backwards and then it stops or then it turns around to go forwards, there has to be a brief instant where we are stopped, and that's when velocity equals 0. Okay. All right. So what do we really want to conclude from this? The thing that I want to point out is when we are asked if speed is increasing or decreasing, and we are looking either at the graphs or equations for velocity and acceleration, what I want you to notice is that whenever the velocity and acceleration have the same sign, so in this case, both positive, in this case, both negative, then speed is increasing. So let's write that down. Let's say when velocity and acceleration have the same sign, and it doesn't matter if it's positive or negative, speed is increasing. All right, so let's go through one example here. We've got several questions that have to do with, so this is the velocity of a bug that is traveling, let's just say left and right because it doesn't tell us otherwise. Okay, and it's, let's see, measured in inches over 13 seconds. Okay, I would like you to stop the video here, try and answer as much of these questions A through E as you can, and then resume and see if you got the same thing that I did. So for the first one, we're looking for the velocity at 3 and 11. That's the value of this graph at points 3 and 11. So labeling V of 3 is 6, and that is in inches per second. And V of 11, that is -2 inches per second. Okay, acceleration is the rate of change of velocity, and we think rate of change, we think derivative and slope. So we're looking at the slope of this graph. So A of 1, the slope here up 2 over 1 is 2, and this is going to be in inches per second squared, or inches per second is fine. Okay, and then a of 5, what's the slope right here? The slope is 0. So 0 inches per second squared. And a of 9, so we have a negative slope. Looks like we're going down 3 over 1, so negative 3 inches per second squared. Okay, part C, at what time or times does the bug turn around? Well, turning around means that our velocity, we're changing direction, so our velocity needs to change signs. That happens once, because we don't know what happens after 13, so once at time 9. Okay. And it does ask us to justify, so we need a statement to go with this. So I'm going to say t equals 9, and I'm going to say because velocity changes signs. If you want to clarify and say changes from positive to negative, that's fine. You do not have to. Just saying changes signs is enough. Saying equals 0 is not sufficient because we could have a positive velocity and then stop and then a positive velocity again. That does not mean we change directions, okay? So at t equals 9 because velocity changes signs. All right, part D, on what interval or intervals does the bug have a negative acceleration? So acceleration is the slope of the velocity graph, and that is happening over the interval from 7 to 10. It looks like that's the only one where we have a negative slope. So we're going to say on 7 to 10 because, so we're justifying with the graph we have, and so we're going to say because v of t is decreasing on this interval, okay? Because v of t is decreasing, or you could say has a negative slope. Both of those are equally correct. But notice I'm referencing the graph that I have and looking at how I got my information about acceleration based on that. So I'm not going to say that it's has a negative acceleration on 7 to 10 because a prime is less than, or sorry, v prime or a is less than 0. If I just say because a of t is less than 0, well, that's just restating what it was in the question. So I need to reference what I have. Okay, and then the last one, is the bug speeding up or slowing down at time 9.5 seconds? So at 9.5, we're right about here, okay? We have a negative velocity, and we have about negative 1.5, and we have a negative acceleration because the slope here is negative 3, okay? So remember, if the slope or if the velocity and acceleration have the same sign, that means that we are speeding up. So we're going to say speeding up because a of 9.5 and v of 9.5 are both negative. Or you could say both less than 0, or you could say have the same sign, whatever is necessary there, but the answer needs to have something about them having the same sign. Okay, last thing on here, and these are already filled out for us, but these are just, if you have a question that's asking you, involves something in this statement, okay, then this is really what it's telling you, what information it's telling or asking, and then this is what we want to look at to solve. So if we want to know, like for example, if we want to know when is the bug moving to the left, well, that means velocity is negative. So we can set velocity equal to 0 and figure out where that velocity is negative, okay? So this is just a handy dandy chart to help you answer these types of motion questions.